Second example, we're going to start by putting the equations in slope-intercept form. So looking at my purple line, I'm going to subtract 12x from both sides. Not losing the negative in front of my 2. Dividing everything by negative 2 to solve for my y. Negative 12 divided by negative 2 is 6. And negative 8 divided by negative 2 is 4. I'm going to kind of combine these steps. I like to solve and then graph right away. So on my y-axis, I'm going to go up 4. And then my slope is 6 over 1. So I'm going to rise 6 and run 1. Or I can fall 6 and run 1. Now with such a steep slope, it's a little bit harder to make that line accurate. So really make sure you try and find those points that you plotted. My right equation, I'm going to add 2 to both sides. And I get y equals 6x plus 2. So graphing this one, I'm going to go up 2. Same thing, rise 6, run 1. Or fall 6, run 1. And trying to make my line really accurate. You may have already noticed, because they have the same slope, that these lines don't intersect. So this would be 0 solutions or no solution, which makes it an inconsistent system. Last example, same process. My red equation, I'm going to subtract 18x from both sides. So I get negative 3y equals negative 18x plus 21. To solve for y, divide everything by negative 3. Negative 18 divided by negative 3 is 6x. 21 divided by negative 3 is negative 7. So I'm going to go ahead and graph this one. Negative 7 on the y-axis. And then my slope of 6, rise 6, run 1. That same steep slope, I've got to be really careful as I graph. Now we're going to take a look at my blue equation. To solve for y, I need to divide by a negative 1. So I get y equals 6x minus 7. Well, that looks familiar. Same line. So when lines are the same, the system has an infinite number of solutions, which means it is consistent and dependent. You try this one.